All right, so let's start with the hands-on session. We're going to continue where we left the second talk yesterday. This is the fourth talk. So we will be basically doing the hands-on on Bayesian networks and trying to get to causal reasoning, although we've discussed this before as well. Just to reiterate that by the end of this lecture today, you should be able to do probabilistic reasoning with complex data sets. If you have interventions, then we can specify those as interventions in the network and do causal reasoning, not causal inference, but you can reason and then design experiments. And essentially look at explainable AI models with Bayesian networks, decision-making and deploying of models. So just as a housekeeping announcement, I'm not sure how many of you have IISER installed on your local machines. Can we have a show of hands? Good number, actually, so that's great. We do have some dependency issues, as you may have noticed in IISER, because the CRAN backend packages, they keep getting updated. And occasionally we run into a dependency which is no longer supported. So some of you may want to, for example, do local installs of the R package called iGraph. Other common dependency issue comes with Viz network, and another is RJAGs. RJAGs is not something that we are going to be dealing with today. That's only used so you'll be able to run the software without RJAGs. JAGs stands for just another Gibbs sampler, which you would know is essentially a sampling approach to conduct inference in optimization and in Bayesian inference. So other than that, so you should be able to actually, those who don't have the local installation, you can actually log in into this link, and we've tested it on a few systems. It works. It's http://103.25.231.39:8899. What it'll do is it'll log you into our server at IIIT Delhi, where we have created accounts for all the participants in the conference. And your accounts should be active, and you can log into your accounts using your email IDs, both as your username and passwords, except if your name is amongst these 1, 2, 3, 4, 5, 6, 7 participants, because these emails were too long. So basically, we have created shorter login password IDs for if you are one of these members. Otherwise, your email ID and password would be the same. So please let me know if you're able to log in into the IIIT server, and let me also go around and probably, because this is hands-on. Sorry. It's the same. It's your email and your email has both the username and password. Great. Anybody who is not, so what do you see on the screen? You're seeing an R terminal. Great. So I hope it works for everybody. So what it should look like in that case is something like this, right? Okay, so I'm just going to log in with my. And if it stays inactive for a long time, you might see that it gets logged out. In that case, you'll have to log in again. So what you can do is you can just type these commands, IISER with a capital and then 2 colons, and then just a small, it'll show up. So IISER with a capital R, 2 colons, and then there is a IISER in small. So what it does is it basically, this is an R Shiny application, just so that if somebody is interested, what we have done is basically built a wrapper, as I said, around about 200 packages, which we optimize to perform because there's no such package which actually allows you to do end-to-end Bayesian network reasoning, inference, as well as decision networks and deployment. So essentially, this is a wrapper around those packages to, and it's built in R Shiny. So if you just hit run, it'll open up a browser window, which will look like this. Are we there? Okay, perfect. So now you can click here or you can go here. Now, since this is a server that we are running on, you can enable parallel computing because we have multiple cores. You can set the number of clusters and turn the toggle on. It'll essentially start building the clusters for you. Okay, so why is this important? This becomes important. This is not so important for smaller data sets, but if you're dealing with real life large data sets and you want to do structured learning, as we discussed yesterday, structured learning is an expensive exercise because you have to, from the space of the plausible networks, you have to find the best network that best explains the data using whatever scoring criteria we will choose. So what parallel computing allows you to do is essentially you will be able to, if we are, yes. If you have 20 cores on your laptop, you can go up to 20. You can't go up to 20. It'll throw an error. So yeah, thank you for that question. Yeah, so why do we need these, right? So for example, when we talk about doing 500 bootstraps, what it will do is if one bootstrap takes 5 seconds, right? Basically, you'll have 500 by 20 bootstraps that will need to be performed. So it'll basically decrease your compute time for the structure learning exercise, right? So now I'm assuming that you already have until this part figured out. Is there anyone who is not here and is not able to see the app settings? Great. So let me go back quickly to the toy example that so we have looked at the accounts, we are sorted with that. So yesterday we got a nice question about what would happen if we had 2 columns which are identical, and then these columns were basically how would you decide the edges? So the answer, I played around, I did some experiments. You can do it on your system as well, but I'll show you how to do this. Essentially, what I found was that this edge is really unstable in this case, B to A or A to B. But what would allow you to make that inference is that when you do the bootstrapping, you can set the threshold to 51%, and you'll see that the edge disappears. That tells you that the algorithm is really not confident at which is the cause, which is the effect, right? The directionality is not clear. So in that case, essentially, you would not have an edge, and the edge would go away. Which makes sense because if you have 2 identical nodes in the same network, the algorithm will just account for one of those, right? And then basically the other one is left out of the network. So there is no, that exercise you can do. So let's actually start with this particular exercise itself, where I'm going to show you on my laptop first, and then we can go to your systems. So the way to do these, so yesterday we said we can start with data sets which can be our own. Just a quick disclaimer: if you are planning to work with your own data, right, which may be sensitive data, please do not work with the server at IIIT Delhi. The reason being that data will go to IIIT Delhi server. because you'll be uploading it, right? So please, I'll be working with the PIMA Indian diabetes data set for this demo. Please do not upload any sensitive data if you are running this server, right? Because then the data will go there. If you're running the algorithm, the Visor app on your laptops or your servers or your own servers, your data are completely secure, right? Then it stays on your systems. So just to ensure that, so just to ensure that you're not uploading any of your data to our servers, right? So if the app is on your systems, your data is secure. It is only on your systems. All right, so you see an upload option here, right? And yesterday we looked at some of these default data sets like alarm, and there's some others which you can also explore. But you can click upload, and this this particular check mark here, I usually like to check it off, right? We will change this to be checked off because we don't know if all the variables are factors, right? And then I can browse for the data sets. And what I did was basically I downloaded a data set which is diabetes.csv, and I'll show you right away where you can get this data. So you can go to so this is the data set, which is PIMA Indian's diabetes database, which is basically hosted on Kaggle. It is a subset of the large study, which is a very famous study. It's used to teach machine learning in many settings as well. But if you just go on Kaggle, kaggle.com, and search for PIMA Indian here on the search bar, PIMA Indian's diabetes database, you will get a link to download this data. So if you can just show hands, once you've gotten here, clicked on download, right? And it'll actually, if you just go on the table here, diabetes.csv, and click on this particular download icon, it'll just download the CSV for you. So what this will help us do is to work with the real world data set, which is health data set on your machines. And then you can also run it on the server. So do we have the data set downloaded? Too many requests where? On Kaggle. Ah. Okay, so no, so what should will I be able to share this on the Zoom chat, CSV file? It's a small file, no. I do have the emails, but I think that will take some time. I didn't anticipate that Kaggle. This, yeah. I do have emails if you want me to send. I have the data on my local. So okay, let me try. Sure. Sorry if it's going to spam more users than intended here. So it might go out to speakers and all other users as well. So, but let me. Can't we share files on Zoom? No. No, this is the only thing. But if you sign in with your Google account, it still says too many requests. Yeah, you can actually download it from there. So that will avoid sending a lot of emails and spamming. So it's www.imsc.res.in tilde rsidd/diabetes.csv. So yes. // after the slash. Could you download the CSV file? Wonderful. So now if you go to IISER and click on, wonderful. Just click on upload and then remove the checkbox tick here, which says variables as factors. I don't know, there's some delay, but and then you can click on browse and just select your data set. Sorry. Oh, really? Yeah. Oh, yeah. You were talking about the P1 India. So, yeah. Yeah. Okay, so how can you have a show of hands? How many of us can see this data set loaded? Super. So that's great. So if you're having any questions for those who have not been able to get here, please do ask. Okay, so now you can see that this data has numeric. Mostly it's numeric, right? And then you can see there's no categorical variable except for this outcome variable here, right? So you can see that there's a variable called outcome, which is 0 and 1, which we would like to be represented as a categorical variable, right? The rest of this can be discrete number of pregnancies, right? So that's completely up to you. You want to treat it each pregnancy as a discrete number, or do you want to treat it as a numeric? The reason I'm saying this is going forward, we'll be discretizing these data. The way IISER is built, it works with discrete data so that we can do inference over classes, right? So for that, what we will need to do is we can go to pre-process. And on pre-process, you can see this function here which says convert variables to factor. There's also convert variables to numeric, right? So you can see that most of the data was numeric. So I had removed the checkbox for factor. Only one column was a factor variable. So I will just use this particular selection to say that outcome is a factor. It's not numeric, right? So otherwise it will treat it as a real number space, right? So we convert this to numeric. It just gives you a warning that data still has numeric variables, use discretization options under pre-process. Why is this important? Because we'll be building discrete Bayesian networks and in this work, right? So So, and then it tells you what to do next. It tells that you can discretize data using preprocess. If the data had missing values, the first warning would have come up, your data has missing values. Okay, so you, in that case, the preprocess tab has a function of imputation here. As we discussed yesterday, we do not recommend imputation if your column has more than 10% or 15% missingness. In that case, it is best to remove that variable, right? So, but if you are fine with whatever level of imputation you have, missingness you have, you can impute the data. The document that we shared has more details on what imputation algorithms are being used. We are using random forests based imputation. There's also other approaches like imputation using multiple imputation using chained equations. So more details are there in that. So once you have clicked on convert variable to factor, you can just click here. I think I already did that, right? So now you can go here and click on discretize. And there's a few methods of discretization that are available again. These are details which are again described in the manual, but there is hybrid discretization, there's Harteming discretization. These are recommended approaches for discretizing data. And then there's other statistical approaches also which you can use. Now, what is this? What is this discretization? What we want to do is, for example, if we are looking at glucose, right? We want to make inferences which are more interpretable, right? So we want to say, what if a person is moving from the low glucose class to the medium glucose class or the high glucose class? How do we do this low, medium, high? That is what we will be doing in discretization. And that can be achieved by multiple statistical approaches. There's quantile-based approaches, which are also quite popular, that you can look at the quantiles of your data and then basically divide it on the basis of the 33rd, 66th quantiles into 3 parts, right? But what we recommend is a hybrid discretization, because it has been shown that if there are natural clusters within the variable, then it's good to create discrete classes by these clusters. Okay, so we choose 3 classes. 3 is k-means clustering with k is equal to 3. And glucose will be looked at in the form of clusters if there are any clusters within that, right? And then basically the cut points for glucose will be decided on the basis of the clusters that are formed. This is a very important step. If you go back to the Bayesian network literature, it actually shows that the choice of discretization algorithm really influences the structure learning that happens down the line. So why do we say hybrid? Because it will try the k-means algorithm as the first approach. Many times there are no discernible clusters in your data. In that case, it will try the quantile based, right? Sometimes quantiles also fails, and then it will try the frequency or interval based discretization. All right. So we will just say discretize here. So if you press this button, you will see that your data probably has gotten converted into classes now, right? And since we had not treated pregnancies as factor, which you could have said, I want to understand what happens when pregnancy changes from 5 to 6, 6 to 7. In that case, I would have treated each of these as individual classes. But most of the times we are looking at these as clusters, right? So here you can see, basically it shows you 0 to 1.9. What is 1.9 pregnancy? You can basically treat it as 0 to 2 births, right? And then you can see the next stratum begins 1.9 to 5.81. Actually 0 to 1 birth, and then there's 2 to 5.8, obviously. So if it doesn't make sense to you, feel free to really change this to a factor variable and treat it as such. Because what is 5.81 pregnancies? But to get a sense, it does give you some understanding of how many pregnancy, what is the range of each pregnancy class, right? So you can also explore that here. Where is it? I think there's some lag. So for example, pregnancies, you can see that these are the, so in the three classes, 0 to 1.9, 1.9 to 5, 5 to 17. Yes. Okay, so, right. It should work. So if you click on pre-process and just click on this button called discretize. It's not giving?
This is all right. Do I have to do anything else?
Oh, it comes.
I mean,
Okay, no. So yeah, all right. So perhaps that's because when you uploaded the data, you did not unclick the upload. Yeah, so this was already a factor. So it's already, okay, so basically, yeah, that's a good point. So if you, while uploading the data here, right, remember to uncheck this, because if it is already treating your variables as factors, if you did not uncheck it, then it is already discretized. It is treating it as factor. In that case, when you discretize, it will not change because it is already discretized. Factor variable is already a discrete variable. So in that case, you'll have to go back, upload the data again, browse, but after, upload only after you've unchecked this box here. It says variables as factor. Now it works? Works for everybody? Great, perfect. So now you see these intervals that you can see, right? And then you can explore these intervals. So this is the P-Indian data that you can go and read about, but it's a very famous data set which basically is looking at pregnancy and diabetes, right? So you can explore, for example, this variable here called glucose, and you can see that the discrete classes that it has formed are from 0 to 105, 105 to 144, 144 to 199. Now you may question that I'm a clinician. Just a second. I'm a clinician and I know what are the plausible ranges of cut points for glucose, right? So for example, if you already know that I would like to have a cut point at 100 instead of 105, you can still do that in the app. You can choose your breakpoints, or you can upload the data after doing that. So this is just a functionality that is convenient. It is based on, as I said, statistical cut points. It may not be the best cut point that you may want it to be as a clinician. I had a question there and then I'll come to you. Please go ahead. Okay, so k equals to 3 essentially is so breaks and I breaks is where you will choose in this case. But I would recommend that basically you choose k equal to 3 if you want to do interpretable inference, right? Yes. Yeah. So, I mean, so here you will just be able to look at PSA as a univariate cluster, univariate analysis. We are looking at, are there any natural clusters within the PSA measurements itself, irrespective of what ethnicity or what other covariates are. So it will not take those into account. It will just try to form are there any natural clusters forming within the PSA variable itself. I didn't get it. So if you load it, yeah, yeah, yeah. Yes, because even within African population, there will be a distribution and there'll be variation. So if you're looking at, let's say, ethnicity and PSA, and if this is Africa, and let's say this is Asia. So even within the African, if you did it separately for Africa, it'll try to find cut points for only this particular section of data set, right? So it'll try to find, are there within the natural variation that's happening within African population, I'm just drawing it as a normal, are there any clusters of points that, that are existing? Right, so that kind of clustering can also be done within this, but if you do these together, then it'll treat this as a single variable, and then you might find that maybe Africa is a different cut point from Asia and so on. Yeah, but this is a completely, I think this is a data-driven way. It is not an intelligent way. So let me just reiterate that point, that in a data-driven manner, we are getting these cut points and these clusters. So if you want to revise those or change those, it's I mean, clinically it's advisable that you can actually load your data in a manner where these have already been coded for, right? Yes. Just a second. Yeah. No, it can be present absent. It can be, that's not a problem. So yes, no will also be treated. It'll automatically be treated as a factor in this. So yeah, but 0, 1, if you had 0, 1, then you'll have to specify that 0, 1 is not numeric, it is a factor. If you had yes, no, ABC, cancer, diabetes, then it automatically takes it as a factor. There was a question. Counts. Sorry, you're not getting this? Okay. So did you go to explore and clicked on any particular variable and you're not getting these? I think there's some lag. With the server, I think there's some lag. So maybe you have to click twice to get to it, right? So, so basically, these, for example, here you can see that this is blood pressure. And in blood pressure, you may not find yourself comfortable with this kind of a binning, right? It's 0 to 33, very few number of, but it just tells that there were some, I don't know, this is definitely an anomaly. Perhaps data cleaning is needed here, but you can see that between the 0 to 33 range, there is about 5% of the data points that are within this range. So you might want to clean this. So definitely would recommend that once you have done the discretization, please do explore to whatever extent possible the bins that are formed and if they make sense to you, because it is important, right? And then you can see the blood pressure is 33 to 74, 74 to 120. Remove outliers? No. Yeah, you'll have to do that in the backend data. How do I choose what? There's a iBreaks function, which is here, pre-process. So you can choose breaks and iBreaks here, custom intervals. Yeah. Yeah. But as I said, I think currently the default we have kept is 3 for interpretability reasons. If you want to change that, there's a couple of methods which I'll talk about later. I mean, so it's not so, we can add that easily, but then we didn't want to add a lot more confusion as well. So, and then there's some other features as well. For example, sometimes as data scientists, we might have just transposed, we perhaps mix the rows and columns. So you can transpose your data, you can sort data, arrange columns, delete variables. You might find that if there's no variation in the column, right? Let's say PSA had no variation at all. Then at the time of structural learning, that variable will throw an error because it doesn't have any variance. Or you want to remove some variables which you think are not important, you can delete them from here, right? And what I recommend is every time you do some operation for reproducibility, so for example, if you've done imputation, I immediately download that imputed data. Why? Because all these algorithms like random forest-based imputation and clustering algorithm, they are stochastic algorithms, right? Every time there'll be a slightly different outcome, right? So when you're publishing a paper, it is important that you have every step of your work documented. So you can choose this download option here and basically download the data set. You can name it as you like, but the way I typically name it is, for example, here I would say discretized diabetes, right? And if I have done a sequence of operations, imputed discretized diabetes, and so on. So basically I would recommend doing that because sometimes it might happen, and we also earlier on made this mistake that we got some really interesting findings in the network, and then when we are compiling data sets together, we realize, oh, we didn't download the discretized network, right? And so it may or may not slightly change, the discretization may change and so on. So do make sure that you're downloading the data sets as you are processing them and keeping it in your folders organized. Just reproducibility exercise. Okay, so now we can directly go to, I think, this first level.
Just one question.
Yeah.
So just to confirm, each variable is being discretized separately, right?
Correct.
So if I want to discretize the data based on one variable, say I want to create 3 quantiles based on blood pressure, the quantiles should be determined based on blood pressure. There are 3 groups. I want to create 3 groups based on blood pressure. All other variables I would like to.
They are not taken into account.
Yeah.
You're doing this column by column. Right? Otherwise, we'll be creating an artificial link between. If I'm creating some blood pressure clusters based on other covariates, right? Then I'm creating an artificial relationship between the discrete categories here and other features, which we don't want. We don't want to create any artificial links in the network. So we are actually treating each column as separate, and then we do the links analysis, right? Yeah. Yeah.
Means giving same number of partitions to all the variables may not work sometimes.
That's correct. So, so for example, if there were 5 natural clusters within data, right? Then you won't, yeah. So then you might want to, for example, we might want to treat as 5 different. That's your question, right?
Suppose you're giving 5 partitions to pregnancy might not work for giving same number of partitions for insulin, right?
Correct.
There may, because their distributions may be different.
Correct. Their distributions are different.
Yeah. So might be better is to.
So the statistical approach is do quantiles, which again does the same thing, or frequency based, which again does the same thing, right? So that's why I said that if you think that there is a domain based understanding for that variable that you can incorporate here. So in that case, you can, so if you really have to just go blindly, I would say choose quantiles. That's what we typically do, the lower quantile, the middle quantile, and the higher quantile. But that's also has the same issue for every variable, right? So basically it has the same issue that obviously the quantiles are also different. Now the question is, there may be different number of clusters, or let's say pregnancies and glucose, which are optimal. Pregnancy may have 5 optimal clusters. Glucose may only have 3 optimal clusters, right? But it is very similar to the quantile problem. We are forcing 3 clusters here. That what are the 3 best clusters? In that case, the 5 clusters, 2 will be subsumed within 1 cluster, right? So we are looking at the level. Remember those cut points yesterday, which Rahul was showing in the dendrogram? We choose where we draw the line to select the number of clusters, and it is our choice that we choose 3. The reason is we can then interpret as low, middle, high. Otherwise, it becomes too complicated. If you want to actually, you can do that in R. There's no, it's not preventing anything like that. It just gets too complicated in terms of interpreting.
Okay. But it might be better if we see the distribution of every variable, each and every variable, and then decide the cluster on the basis of that, because number of variables may not be very high, right? Sometimes.
So in that case, I would recommend that you actually do it before. I mean, this is a convenient reference. Can't do it. So you do it before in the EDA step, right? So in every machine learning analysis, you would start with exploratory data analysis. And in exploratory data analysis, you could do all of those and then actually discretize. You find the optimum number of clusters, right? Because there's no way, if there were 1,000 variables in IISER, to tell that do these many clusters for this variable and do these many for this variable. We can choose things like silhouette, etc., but then it basically just becomes a very tedious and messy affair. You should do that, but then do it before you bring in the data into IISER, right? So just use a k-means algorithm in a loop over your variables, and then basically choose the best number of clusters that you want, right? So same applies to domain-based also. There may be 5 domain-based cut points for glucose and only maybe 3 for skin thickness. Those things should be done before data are brought into IISER.
Thank you.
Okay. Are there any other questions? All right. So is there a question? So then we can go to associations, right? So as you remember, yesterday we were talking about associations. I'm going to set a, so you can choose various, since it is categorical associations, these are the recommended ones, right? So let's just choose a Cramer's V and start building it, right? And you'll see that the association now graph is built. And you can see that there is no directionality here, right? And as you change the threshold of association, the network will become sparser and sparser. But this gives you an idea. Why is this important? In every machine learning analysis, as I said, EDA is important, right? Even once you have gotten to the advanced stages of machine learning, always visualize what is happening. So it gives you a sense that things that stay, even build is not showing. That is not showing up if you have a threshold which is high. Can you just slide the threshold to a lower threshold? Dr. Suresh, if you just slide the threshold to a lower, does it come up? This is fast. Not showing up for you also? Your threshold is probably too. There's definitely something. And you're running this on server or local? Server. But this is
Just show the nodes.
no, yes, so no, but it doesn't show the nodes. Okay, so this is a new thing that, so I'm not sure because we are running on the same server. You're also not seeing it?
Maybe.
Maybe there's a lag, too many requests, I don't know. Yeah, there seems to be some server because some of you have got it and both of you are on different machines, right? That's a Mac, this is a Windows machine. Yeah, because we are on the, sorry. That's interesting. So yeah, I'm not sure why is this happening that on server for some of you, the association network is not showing up. So my first thought was that probably you are setting the threshold too high, in which case, for example, if you set it too high, it disappears because there's no connections. But if you bring it to a lower threshold, you'll start seeing something like this emerges. Maybe there's a lag, I'm not very sure, but build here. That select by ID is just, yeah, that's just a way to highlight nodes. It'll just highlight the node. Right, and then you can see that there's an associated table that you're getting here as well. I guess the table is still coming for most of you, right? You have two variables and a strength of association. However, when you run it on your machines, local installations, this should work seamlessly. This should not be a problem. I've never seen this issue before where it is not showing up for some of the machines. And then we can go to essentially, this gives you a sense of what the association network looks like, right? And you can see what are the nodes, some of the nodes, for example, if you're interested in outcome, right? It gives you some sense of how tightly is it connected to various other features in the network, right? And basically, this just gives you a sense of how are things correlated amongst each other, right? We have an experimental module. I don't know if it, we have not looked at it in a long time, which was modularity detection. I can try if it still works using the WAD-D distance metric. So I would not recommend doing that. So I think there's some dependency issue here. But what we were doing before was detecting what were the modules in this association network. So this was experimental and we can ignore that for now. But if you go to structure, which is next. So we went from app settings to data to association network to structure. And on structure, you have structure learning here, right? You can click on structure learning. These are the options that came up yesterday, or are you right? So does anybody remember? Now we have a data set which has been discretized. We have done all the quality checks, assuming we have done all the quality checks. We have looked at the distributions. We have looked at how the association graph looks like. You want to build the Bayesian network structure on it. So what will you choose here within the structure? Out of these options, what will you choose? Learn structure, because we don't have a prior structure to begin with, right? So we'll just go to learn structure. And now you can see these options that are available, which are learning algorithms, scoring criterion. Then you have blacklisting, whitelisting, parameter estimation for the inference. You can use Bayesian or the maximum likelihood approach. And again, you would have some recommendations. So can you look at these score-based learning approaches? So you can see hill climbing and tabulated search-based algorithms. So let's just click on hill climbing, right? And for the first time, you can just scroll down and click on one time, right? Because we're just starting out. And it is a small data set, so it did not take long. So is everybody able to see this? Just a second. You had a question? So that's a problem that I think that's exactly what I'm saying. I'm not sure why the network is not showing up for some of you when you're trying it on server, but on local it is coming, right? Yeah, so on local machines it should come. Actually on the server it should also come, but I'm not sure why that is happening for some of you. You had a question? You had a question? Those on the server, can you just ignore that error? WB file not found error. Can you just ignore that error? It will still work. Yeah, so then basically I would say you will have to install it on your local machine, because I'm also running it on the server, right? So this is coming up, and for many of you it is coming up. So I think that is a behavior that probably is not an app issue, but I think it is a server issue. So I don't have a ready solution for that. But if you are running it on your local machines or your own servers, this should not happen. Sorry? Why will it run 2 instances? I'll come to that. You can, I mean, it's up to you, the threshold that you want to choose. You want to, for the one-time network? Yeah, so there's no threshold here. So when I'm doing structured learning, it is a stochastic algorithm. If I do the one time again, it may not be exactly the same. So you can see this here, right? So basically there's pregnancies, and this is a structure. This is using Bayesian information criteria. If I repeat it, it may not exactly be the same. Yeah, okay, so this is the second time. So you can see, so let's look at some of these. So for example, outcome and pedigree function, and then there's glucose that is going in, and then it is going into the pedigree function, right? Let me do it one more time. You can see again, this time also there's outcome, glucose, outcome, pedigree function. But what I'm saying is this may not come up every time, and that's the reason we do bootstraps. Okay, so here, for example, again, you are seeing outcome, glucose, outcome, diabetes pedigree. So this seems to be something which is coming up every time on all networks, right? But what I would recommend is that we actually do a bootstrap to confirm that. So let's do maybe 101 bootstraps. Okay, is everybody with me? What are we looking at? So we did one-time network learning, but we cannot be confident about a single structure that has been learned, right? Because there's a lot of stochasticity. So we can't be really confident about this structure. So what we would like to do is we would like to construct more networks by choosing subsets of the same data. And how do we choose subsets? We are doing sampling with replacement, which is called a bootstrap. So what is a bootstrap? Just for the purpose of introduction, let's say you have a table from 1 to 100 rows representing samples, and these are variables along columns. A bootstrap is an approach which is a resampling strategy. Resampling means we can sample from this entire data set. We can pick some samples from this data set, but with 2 constraints, that we do it with replacement. If I choose a sample, I put it back into the bag so that it can be picked up again, right? So it is sampling with replacement and keeping the number of samples the same as the original data set. So we create an artificial data set in which there can be there can be, for example, 3 that got selected, maybe it got selected again, and then maybe 4, 5, and 5, and then 6, 7, and so on up to whatever. The number of the rows will be 100. 1 and 2 are not present in this data, right? So Brad Efron showed that this bootstrapping approach allows you to estimate the population parameters closely by choosing this resampling strategy in some asymptotic limits, right? So it is a good way to basically create samples from your data, right? What can be other ways? You can perhaps just choose a smaller sample from the data, right? Just pick maybe any randomly 10 rows from the data. Data set. Each data set will be slightly different because each one will have slightly different samples picked up. Okay, so what are we going to do? We are going to basically pick up the but this screen went away. Sorry, this is not required. So I was presenting my own screen, which has gone away. Oh, you have to share again? Sure. Perfect. So we'll do 101 bootstraps and keeping the rest of the parameters same, hill climbing algorithm, which is an optimization algorithm, as we discussed yesterday, using the Bayesian information criteria. And you can also play with this. The other criteria is the AIC, a Kaike information criteria. And when you use that, you'll see a more connected network because Bayesian information criteria prefers sparsity of variables, right? So basically it will prefer a more sort of a parsimonious model to be built. If you choose a Kaike, you'll see that it will be a more dense network. But let's just keep it same for the moment and just click on, so the other things that you can see here are edge strength and direction strength. So let me choose 51, 51. You can choose anything above 51 as you would like it to be. But does anybody remember why 51? Majority voting, right? We are constructing 101 networks, an odd number. So at least 51 have to say that 50. So we are learning 101 networks on those 100 resampled data sets. And then at least 51 networks should vote for each edge if that has to be present, right? And the direction if that has to be present. You can make it higher and you'll see that the network will become sparser. Okay, so let's go and click on Bootstrap. This was fast because probably we are running 20 cluster, right? We set up the parallel computing in the beginning. So you can see that now there's a much sparser network that comes up, right? At the level of confidence that we have set in the Bootstrap as, it's not a level of confidence statistically, but essentially what we are saying is that this is the network structure which has passed the criterion of 51% majority voting. And you can see that this one still comes up outcome, glucose outcome, diabetes pedigree function, and there's 80% of the networks voted in favor of this edge. Here, 100% favored this edge. All 101 networks said that there's something between glucose and outcome. I'm not an expert in the PIMA Diabetes Indian data set, but if somebody has some insights, maybe if you've worked with it, you can comment. But what we see that there is something that's immediately coming up here. Now, the next question is that you can see there is ingoing and outgoing edges. Yeah, just a second. You can see that there's incoming and outgoing edges out of outcome, right? But let's say if you wanted to enforce that outcome, since it happens later, cannot lead to an outgoing edge. That's where we will again, so we were basically looking at features such as blacklisting yesterday, which allows you to incorporate prior understanding or even the sample or even the study design, right? For example, if something happens at the start of the study which influences something later, which means there's a temporality, you can actually enforce that temporality of relationships in this. Question? Sorry? Okay, so yeah, that's when we do inference. Okay, so I'll come to that, and please do remind me. I'll come to that when we do inference. That you'll see these are just colors, which we'll color the nodes with, just to remember what are we setting evidence on, what are we looking at. I'll come to that. Okay, so but I'm going to demonstrate two things right now. So one is that this network structure, as I said, so for example, these have high confidence because these are all one. So all 100% of the networks have voted for these. You can see that there's some edges which, for example, this one, the relationship between blood pressure and skin thickness is 77% networks voting for that, right? There's some age and blood pressure relationship which you can query and come to some conclusions. But you might also want to play with the other network criterion, scoring criterion, which is AIC. Right? And do the same exercise, 101 networks, 51%, 51. Okay, by the way, every time you learn something, please do download that so that you save your work. So you can, for example, say save bootstrap object, right? And I typically give naming convention as it doesn't come up here. I would give the naming convention here as 101 boots. BIC, because I chose the BIC criterion, and then 51, which was the threshold, and this is up to you. The file name is just a reminder to, okay, you can't see here. So the file name is just a reminder that I'm choosing 101 bootstraps, BIC as a criterion, and 51% as a threshold, right? So basically, please do save your work, save your objects. What you can do with that object is next time, this was a fast learning exercise, but if you're working with large data sets, sometimes you might take a couple of days to learn the network, right? You don't want to do that again. In that case, you can just download it, and next time when you load your previous data, which you had saved, you can just say upload pre-learned structure, right? So you can just upload your previous structure that you have saved, upload your previous data, and you will be set up for the further experiments. That's also helpful if you are doing transfer learning across sites, that if I downloaded that network that was built for AIMS, and now I can actually upload that, initialize the new structure for, let's say, another site, right? So what we'll see now is use of Akaike information criterion without blacklisting anything or whitelisting, which we'll see in a bit. And then we go to the same option here, which is bootstrap, and we click there. And now you can see that using AIC, which gives you a more connected network. Same number of bootstraps, 101 bootstraps, right? Same criteria, 51%, 51%, but the BIC network was sparser than the AIC network. Does everybody agree with that, right? So these are two different approaches. If you want to have a sparse network, when would you do that? Let's say you are trying to find a model which is parsimonious, minimal. You want to look at, you want to do some feature selection, getting to the bare minimum number of variables that you want to collect on the field, because collection of each of these features is, let's say, expensive. In that case, you might choose the BIC based networks. AIC based networks are slightly more connected, as we can see, because they also help with model selection, but they favor more connected networks. And here you can see that, again, you'll see that this outcome and glucose and diabetes pedigree function, right? It's following the same direction. So we have tried two different approaches using BIC and AIC, and they're giving, I'm just focusing on this. You can also look at other parts of the network, but since this is probably of importance, right? So you can see that there is a same kind of a direction that's coming up in each of these. I'm not saying this is causal, but yeah, just as. Why are the directions important? So you can make it, so you can ignore the directions further, right? So you can ignore the directions if you're doing reasoning. Probably because it is a directed acyclic graph. Yeah, so sorry. It is not causal, okay? So that's, I think I've said that many number of times in these 2 days, that please do not interpret as pregnancy leading to age. But it tells you in a probabilistic, sorry? It just tells you that if you know about pregnancy, you can actually make a more intelligent guess about age. Let's put it that way. No, but that is the direction that is favored by the data, right? So which one will allow you, which one will change more of your belief? It's a belief network, right? Knowing what will change the belief about the other is the question, right? So knowing about pregnancy changes your beliefs about age more than knowing about age changes your beliefs about pregnancy. That's the way to interpret it. It doesn't mean that pregnancy causes age. So knowing pregnancy status changes your belief about age more than changing than knowing age changes your beliefs about pregnancies. That's why it is reasoning. It's probabilistic reasoning, not causal. And why do we need these directions? I think yesterday's class was that the world is asymmetrical, right? So you may ignore these, but you may also take support of these to make reasoning systems. Is it? I think that was an important question and an important point to make. Please do not interpret that pregnancy causes age. It just tells you that if you knew pregnancy status, you can make a more intelligent guess about age than the other way around, right? That if you knew about age, you can still make a guess about pregnancy, but that will be less intelligent than the other way around. I hope that is clear. So what will we now do is essentially try to incorporate a blacklist. Okay, so let's say, and I'm not an expert in this data set, I've not worked with this cohort, so this is just a very well used data set, so I think that's why I'm just saying that I'm assuming that outcome is something of interest to you or to me, right? So what I would do is I would say that I want edges only pointing towards outcome, because it is, I can build reasoning systems, right? So I can enforce, or if there's some temporal causality that things in the past can lead to things in the future, I want to enforce that, right? So what I will do is basically I will use this blacklist operation, and I think I will not be able to share my Excel. Let me see if I can. So what I did was basically construct a simple blacklist. Yeah, it will not come up. Let me just reshare it. Stop share. Okay, so this is the way you would actually create a blacklist. Here's a very simple blacklist where I say that things can go into outcome, but things cannot go out of outcome, right? So I just blacklisted, this is from, this is to, this is just a convention that's there in the manual, that you are preventing any outgoing edge from outcome. So you just copy paste the variable names other than outcome, and here you write outcome and then basically fill this edge list. You can also do this programmatically in a large network. That's what we do when we are building large networks. But here it's a really straightforward comma separated file to build, where you'll say outcome cannot go into pregnancies, cannot go into glucose, and all of these, right? And then you just choose this blacklist file in your network, and I'll just show you how to do that. So browse, and then I had blacklist, right? And when I learn now, bootstrap network, no, I think the blacklist did not get uploaded. Yeah, it said file upload job was stopped prematurely. I don't know why. This is the first time. Let's see if it works this time. No, so this, I think, I don't know why uploading is not working on the server. This should not happen on your local machines. Let me try one more time. No, so it's saying file upload job was stopped prematurely. I think the server has recognized that we are uploading files. So there may be some firewall rules that is preventing the uploading of the blacklist. I think I saved the network. That will also help us upload pre-learned network, which was a bootstrap network with 51%. And I think that was saved as, I don't know if it was the, no, so it's not allowing any uploads to actually happen on the server anymore. So we are stuck with this network for now, which should not happen on the local machines. But if you were able to actually run that, we would see that the variable outcome would only have incoming edges. And now if you have done this exercise, going through all the steps that, for example, bootstraps and 51% or maybe more confidence, right, and choosing the right thresholds, now you are ready to go to inference, right? So for example, now you can start querying the network that if let's look at glucose and outcome, right? So if glucose was in the lower range, what happens to outcome? Right, so you can see that glucose here is 0 to 105, 105, 5 to 144, 144 to 199. You can choose what range do you want the glucose to be in, and then what happens to the outcome variable, right? And then just choosing the error bars. So you can see that the outcome was 0 in most of the cases in which glucose was in the normal range. I don't know what 0 and 1 were, but we can go back to the data to know that. So if I go to the higher glucose, medium glucose range, and you can see that the probability of the outcome 1 has gone up, the probability of outcome 0 has gone down. And if I go still higher, you can see that the probability of 1 is 71.7%. So essentially this tells you that I have not looked at this data. Today morning I actually downloaded and worked with this data to just set it up as an example. But just one variable in this network, which we may know to be important, which is glucose, is actually telling about the probability of the outcome in a strong manner, right? And then there's others which you can also use to make such predictions. Remember, this is not a classification model. This is a reasoning model, which this can be used in a classification scenario down the line by choosing variables, by doing Markov blankets, as we discussed yesterday. So now you were asking about event and not news, right? So when we go to inference, we see evidence and event, right? So event is outcome. So we are setting evidence for something, and then we are looking at what happens as an event, right? So it's not a epidemiological terminology, but something that you can relate to, right? And if I actually refresh the network, you'll see some color changes here, right? So basically, this is the outcome, and this was the evidence that we had set. Now you can see that in the network, basically we had set evidence that glucose was low, and then we are looking at the outcome event, what happened to that, right? So this basically is a very brief, small toy example of going from association to structured learning to inference. As I said, you'll have to interact with the network, come to a confident net. Most of the times, I blindly follow this procedure. I basically first do the one-time network to see if there is anything that this data has worth exploring, right? If there are a lot of connectivity, then I go to the bootstraps. Typically, I go to 1001 or 501 bootstraps, choosing the BIC criterion, because I want to see what is the most sparse model that explains the data. What is the parsimonious model that explains the data, right? So many times it happens that that model is too sparse, right? I want to gain more information. Then I go to AIC. The same sequence that I followed today is what I also follow in our papers, in our practice. And then basically you have to substantiate in your paper why I chose this, right? Why did I choose the AIC criterion? Why did I choose 501 bootstraps? That you can write about. As long as we transparently report all of these things in our papers, there's usually no challenges. Reviewers may come back saying that, did you try the taboo search algorithm? And you may provide evidence that it won't change with taboo search much and so on, right? So, but as long as you're documenting everything, going as you're doing these analysis, downloading the processed files, the networks that you are working with, you will have the right set of package of things to basically construct the argument for the paper, right? There's some other things as well. So there's a tutorial that walks you through. I think I did not build this with vignette. So if you build it on your local machine, saying that build vignette is equal to true, in that case, it will actually build the entire tutorial into the network. There's also other things like publishing your dashboard, which means that you can just give a name to it. For example, this is tutorial example. Choose a theme and build a dashboard. Again, something that breaks on the net, on the server, which should not have broken. It will basically construct a R package for you, which you can actually install and deploy it as a dashboard for any settings, right? So I think since it just broke, I'll have to reload it, and that'll start it from the scratch. But we are at the end of the tutorial anyways. So let's see if there's any questions. And I'm sorry about the things that did not work on the server, just because we did not anticipate things that might break on the server when we are accessing it from outside network. But if you have any issues working with local machines on your own systems, please do let me know, and we'll be happy to help. Let me see if it's actually yeah, the previous work went away. That's why it is also important that you save your work as you go along. I won't lose time. If I have to do it again, I'll just go to upload. This time I can choose variables as factors because I've already discretized the data. So I'll just say discretize diabetes, right? So it'll upload the data for me. I go to structure directly, structure learning, upload pre-learned structure. It was a bootstrapped structure with 5151, right? And I just go and load the file, which was 301 bootstraps AIC. And you can see I'm back at where I stopped before it crashed, right? So you won't lose your work if you are saving your things as you are going along, and then you can upload everything. So I'll stop here. I know we are running almost out of time, and we'll be happy to take questions. Yep. Yeah. I would not say affecting, right? So basically affecting does have a connotation of causality, right? I'm saying reasoning, that it changes my beliefs about knowing about this. Remember the example that we had yesterday? Knowing that the grass is wet and the sprinkler was on, my beliefs about rain changed. No. So we can talk about causality if we really had interventions in our data. So when you did something and that variable is a part of your data, you'll specify that as intervention variable. There's an approach that you can specify intervention variables, which will make it more causal. But then again, I would say you'll have to validate that. Just with data and models, causality is a very hard outcome to achieve. So I'm saying that you can do causal inference with that because these models are built for causality, right? But causal inference is it's a tall claim, right? So you will have to really go through all the checks and assumptions that have to be met for causal inference. There's a set of criterion that you would want. Yes, but you still cannot infer and say this is causing that, right? But that is true for any other model as well. Even the Don Rubin's approach, that there we are completely going blind. You don't even know what may be confounding. We are assuming and things. So this gets you closer to causality, but anybody who is doing causality will tell you that it's a tall claim if you are actually making claims about causality from observational data. If you had a trial data, interventional data, then yes, but not from observational data. Any other questions? All right, then I think we can close the session. Thank you. Yeah. Yeah. We are not tracking the users. I think we actually, we just launched it as an R package. There's a way to cite it. If you just go citation visor in R, you'll see how the way in which you can cite this. but since we have not deployed it as a web application, so we can't track how many, but from GitHub, we can track how many.
Gotten back to you saying we found this useful.
Oh, yeah. So
Yeah.
basically, I think, yeah, mostly clinical audience and also data science audience, they've gotten back, and yeah. I'll just make one quick, I think, right in time for this announcement. I have 2 minutes. So there is a program that we are launching on postgraduate diploma for data science in health and climate. So sorry for this shameless plug, but let me just introduce this audience to that program also. It's a program which is a 36-week diploma program in data science for health and climate change for social impact. It's a program supported by data.org in collaboration with Art Park, which is here in Bangalore, and JPAL. And it is targeting professionals, clinicians, nurses, policymakers in the government who run programs, NGO data scientists, and so on. If you want to get training in this space, the fee of the program is really subsidized because we are being supported by data.org. So it is for the entire 1 year duration is only 25,000 rupees, which is just for library access and so on. But after 2 years, obviously it goes to much higher, maybe 10 times price. That's our standard PGD pricing for IIT Delhi. It's expected to start in end of August 2023. We are almost on timeline. But if you want to know more about this and are interested, please write to me, and the site is dshcs.iitd.ac.in. It's a 2-semester long postgraduate diploma program in hybrid mode, so both online, offline, and internship opportunities at JPAL and Art Park is what we already have as partners on board. So thank you so much for listening patiently.